Welcome to Vectors 8.3. Definition of vectors, how you add them together, scaling, multiplying by something, definition, that doesn't necessarily mean anything. How you add and subtract these things is important. And then your ij form, that's just putting I and j in front of the two positions of your vectors, and then the horizontal and vertical components, how you find the actual degree and the magnitude. So let's get into what each of those things are. All right, so each of these we got to find a plus b, a minus b, 4a plus 5b, 4a minus 5b, and the magnitude. So we'll make a little chart here. All right, so a plus b, just add the things together. All right, so let's just make this a nice grid, and we'll do our answers. So let's go ahead and do 2 plus 5. 2 plus negative 5 is negative 3. And negative 3 plus negative 1 is negative 4. A minus b, 2 minus a negative 5. So we're just doing these things, a and b, together here. So 2 minus negative 5 is 7. And negative 3 minus a negative 1 is negative 3 plus 1, or negative 2. 4a, this is going to be 8 and negative 12. And 5b would be negative 25 and negative 5. All right, so we subtract that. 4a minus 5b, 8 minus a negative 25 would be 33. Oh, we're due, that's this one. We add them. 8 plus a negative 25 is negative 17. And negative 12 plus a negative 5 is negative 17. We subtract negative 12 minus a negative 5 is negative 12 plus 5. Negative 12 plus 5 is negative 7. And then the magnitude of a, that's where we square each of the values. 2 squared and negative 3 squared, so 4 plus 9 is 13. And then you take the square root. So the square root of 13. Okay, let's keep going. Let's just do all the a plus b's here. Negative 2 plus 2 is 0. Negative 3 plus 3 is 0. Negative 7 plus 0 is negative 7. Negative 2 plus negative 2 is negative 4. And here we have 10 and negative 8. And negative 6 and 0. That's how we look at these. So we add them together. What do we get? That's 4 and negative 8. And this will be 1, 2, if you're wondering. And this is 3, negative 5. So we add those together. We get 4 and negative 3. And then on this one, negative 3 and negative 3 is negative 6. 1 and 1 is 2. Okay, now a minus b, let's subtract them. That's negative 4. And negative 3 minus 3 is negative 6. And I think I made a mistake here. I just didn't see this negative out in front here. So that's negative 7, positive 2. And I add that to and this should be 0 and negative 6. Okay, so when I didn't see it just go. So that should be negative 7 and negative 4. Okay, so on the minus sign of 3 here, negative 7 minus 0 is negative 7. Negative 7. And 2 minus a negative 6 would be positive 8. So that's a negative 7. Sorry, it's hard to see that. And number 4, 10 minus a negative 6 is 16. And negative 8 minus 0 is negative 8. Number 5, 1 minus 3 is negative 2. 2 minus a negative 5 is 7. And down at the bottom here, negative 3 minus negative 3 is 0. And 1 minus 1 is 0. Okay, 4a plus 5b on number 2 here. So we need to write those in there. 4a is negative 8 and negative 12. And 5b is 10 and 15. All right, so let's add those together. Negative 8 and 10 is 2. And negative 12 and 15 is 3. And at the bottom, we've got to figure these out. Okay, so number 3, 4a would be negative 28, because you got to have the negative in there, and 8. And 5b is going to be 0 and negative 30. So add those together, negative 28 and 0 is negative 28. And 8 and negative 30 is negative 22. Same thing on number 4. Let's multiply those out. Let's use a different color. 4a is 40 and negative 32. And 5b is negative 30 and 0. So we add those together. 40 and negative 30 is 10. Oops. And negative 32 and 0 is negative 32. Same thing on number 5. 5a is 5 and 10. And this is going to be, I'm sorry, not 4, but that's supposed to be 4. 4a is going to be 4 and 8. And 5b is 15 and negative 25. Now, they have them in the IJ form in the book for the answers, but that's okay. Add these together. 4 and 15 is 19. And 8 and negative 25 is negative 17. And then again, let's get the blue values here. 4 times a is negative 12 and 4. And 5 times b is negative 15 and 5. Add them together, and we get negative 27 and 9. Now we're subtracting all those. Again, on 2, and multiply that by 4, I get negative 32. Oops, I already have that there. That's the negative 8 and negative 12 there times 4. Okay, so we have those there. Negative 8 minus 10 is negative 18. And negative 12 minus 15 is negative 27. Subtract on number 3. Negative 28 minus 0 is negative 28. And 8 minus a negative 30 is 38. And now the blue one's negative. Let's see, 40 minus a negative 30 is 70. And negative 32 minus 0 is negative 32. All right, number 5. 4 minus 15 is negative 11. 8 plus 25 is 33. And number 6, negative 12 minus a negative 15 is plus 15, so 3. And 4 minus 5 is negative 1. Okay, now we do the magnitude. So we need to make sure we have the right things here. So a on number 2 is 4. Square each one and add them together. So 4 and 9 is 13. Square root of 13. On 3, we better use the negative 7 and the 2. So that's 49 and 4 is 53. Okay. And number 4, that's 10 and negative 8. So 164. And then you take the square root. And number 5, 1 and 2 is 1, and 1 plus 4 is 5. And on number 6, 9 plus 1 is 10. So you're squaring each of those entries and taking the square root. Add them together and take the square root. All right, let's move on. All right, so we're going to sketch the vectors. All right. So we're going to graph each one of these, and we may have to erase a little bit to get these right here. So graph A, vector A here. So vector A is at 3, 2. Okay, there's A. B is at negative 1. This is A. Negative 1, 5. So that's B. And now we're supposed to do A plus B. So A plus B is 3 and negative 1 is 2. And 2 and 5 is 7. So 2, 7. So this would be A plus B right here, which is the diagonal of a parallelogram. And now do 2A. 2A is 6 and 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And notice it's the exact same line. So this would be 2a. And then we have negative 3b. Negative 3b is positive 3 and negative 15. All right, so 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 15. Way down here. So that'd be negative 3b. Okay, that's how you do that. That's number 7. I'm going to erase the bottom part of that. All right, now let's go to number 8 and do the exact same thing again. All right, A is at negative 5, 2. Okay, there's A. B is at 1, negative 3. And A plus B is negative 5 plus 1 is negative 4. 2 plus negative 3 is negative 1. All right, so negative 4, negative 1. So this would be A plus B. Now 2A is going to get me to negative 10, 4. So I need to move everything, or at least this part, over. So negative 10, 4, 8, 10, and 4. So that just extends A further. So there's 2A. And negative 3B. So negative 3B is at negative 3 and positive 9. So this is negative 3B. Okay, good. Number 9. Let's see here. A is at negative 4, 6. Okay, here's A. And B is at negative 2, 3. And A plus B is negative 6, 9. So 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. So pretty crazy. That would be A plus B. And now 2A is extended to negative 8, 12. So negative 8, 12 is right there. So it extends A, kind of overlapping here. They're all on the same line. And negative 3B, it'd be negative 6, or excuse me, positive 6, negative 9. 6, negative 9. That's all on the same line. What do I have for B there? B doesn't look right. Negative 2, 2, 3. Yeah, B is, I went over negative 3 and up 3. So negative 2, negative up 3 should be right there. So I put B in the wrong spot. All right, let's do number 10. Okay, number 10. A is at 2, 0. So let's get our graph on here. 2, 0. So that is A. And B is at negative 2, 0. Opposite direction. So A plus B, if we add them together, you get 0, 0. So the opposite of your vectors go opposite directions, okay? And so that was A plus B, it's just a point. And 2A just goes twice as far. So there's 2A. And negative 3B goes 3 times as far, but in the opposite direction. So it goes to 6. So negative 3B is in the opposite direction. Okay, so the purpose of these are to use the vectors you have, if you didn't know the values, to try to visually know where things are going. So if we look at number 11, A, if we want to get our values here, let's just put A up here so we have these. A is at 2, 0, B is at negative 1, 0, and C is at 2, 0. and D is 0, -1. E is at 2, 2, and F is at 1, 2. All right, so there's all our factors, okay, our vectors. So number 11, A plus B is going to get you 1, 0. All right, so 1, 0 is right there. All right, well, what would that be if I had to use the figure there? Well, I could say half A, or I could say negative B, and negative B is the actual answer. So now I do number 12, which is C minus D, and C is at 2, 0, 2. That's not right. 0, 2. I put that in there wrong. Okay, so C minus D, 0 minus 0 is 0. Okay, and then 2 minus a -1 is 3. All right, so 0, 3 would be up here. That would be C minus D. All right, so I could use C and use some sort of fraction to get there, but D is 1 unit. So if we multiply that by 3 and go the opposite direction, so we would say -3D would be the correct way to say it. All right, 13. B plus E. B plus E. All right, so -1 plus 2 is 1, and 0 plus 2 is 2. All right, so 1, 2 is going to be right there. That's F. So we just say that answer is F. All right, that was easy. 14. 14 is F minus B. F minus B, let's see, 1 minus a -1 is 2, and 2 minus 0 is 2. 2, 2 would be E. That's actually on there. All right, 15 is B plus D. So B plus D, -1 plus 0 is -1. 0 plus a -1 is -1. So -1, -1. So that's right there. So that's half E, but in the opposite direction. So negative puts it in the opposite direction. So that'd be -1 half E. And then 16 is E plus C. E plus C is 2 plus 0 is 2. Okay, and 2 plus 2 is 4. All right, so 2, 4. That's going to be way up there somewhere. So it looks like maybe it's using F. Let's see, 1, 2, 2, 3. No, that would be all right. Let's see. 2, 4. Yeah, it is on that one. So it's the same. Up 4 and over 2 is 2 over 1, which is the same thing as what F is. F is up 2 and over 1. So it's double what F is. So 2F in the same direction. All right, moving on to our next set of problems. Find the magnitude of the vector and the smallest positive angle. All right, so the magnitude is going to be 0 squared plus -5 squared, and you take the square root. All right, so the magnitude of A equals 0 plus 25, or square root of 25, which is 5. All right, now, how do we find the theta again? So you can use horizontal component or vertical component. So we can use the vertical component, -5 sine of theta. That's going to equal, -5 equals the magnitude, which is +5. So -5 equals the magnitude 5 times the sine of theta. All right, so now we divide by 5, we get -1 equals the sine of theta. Take the arc sine of -1. Where is y -1? At 270 degrees. And there you have it. So the magnitude's 5, and 270 degrees is your angle. 30 is the same thing. Now think about what this is. Visually speaking, 29 and 30 both tell you exactly where they are. It's a vertical vector going up. Number 29 was the vertical going down. So this one's going to be 90 degrees just by looking at it. And square both of those, add them together. So 0 squared plus 10 squared is 100. The square root of 100 is 10. So the magnitude is 10 and the direction is 90 degrees. Now 3, -3. Again, I'll just point these out on a simple graph here. 3, -3 is a 45-degree reference in the opposite direction. So this will be 315 degrees. But again, we got to be able to figure these things out without the unit circle, which we will get to here in a second. And then so find the magnitude. Magnitude of A is equal to 3 squared plus negative 3 squared. That's 9 and 9. That's the square root of 18. Okay, so the square root of 18 is 4.2. So that's your magnitude. And, oops, I just meant to put a comma there. And the direction is 315 degrees. All right, so now 32. Let's just go ahead and do the magnitude to get it out of the way. So negative 2 squared plus negative 2 squared of 3 squared. So negative 2 squared is 4. Negative 2 squared is 4, and the square root of 3 squared is 3. So 4 times 3 is 12. So this would be the square root of 16, or 4. That's our magnitude. So now we can use the horizontal component, negative 2 equals the magnitude times the cosine of theta. Divided by 4, we get negative 1/2 equals the cosine of theta. So where is the cosine of theta? Negative 1/2. So on the unit circle, the x is the short leg and y is the long leg, all right? But it's negative 1/2 down here as well. So now you look at what you have here in your vector. Your vector is negative, negative, so it's in the third quadrant. So we're working on this one right here. So what is that value? Okay, so it's a 60-degree reference, 240 degrees. So magnitude is 4, and 240 degrees is your reference. Now I'm going to talk about how easy this is to actually do without the horizontal or vertical component form. Okay, you do need to use those for something, but and this is not too difficult. So the magnitude, again, A equals 4 squared and 5 squared. 16 and 25 is 41, so it's the square root of 41. On the vector, we're left 4 and up 5. So we're in the second quadrant. All right, so now we need to know theta. So we can use the horizontal component again. Negative 4 equals the square root of 41 times the cosine of theta. So negative 4 over the square root of 41 equals the cosine of theta. So you do the arc cosine, second cosine of negative 4 divided by square root of 41, and we get 51 degrees. All right. I forgot to put the negative on it. I thought I hit it, but it should be 128.7 degrees. So 129. It doesn't say what to round it to. So 129 degrees. So that's your theta. So I want to teach you something here. This is your x and that's your y on 33. So why not just do the arc tangent of 5 over negative 4? So put that in your calculator and you get negative 51 degrees. Now remember, tangent is a 180 degree value to look at. So one's positive, one's negative. So that means going down here is negative 51 degrees, and 180 degrees the other way is going to be 129 degrees. So you could do that as well. So those of you watching the video, congratulations. This was a fast way of doing it. So you could do the arc tangent of 7 over negative 3. Again, where are we? X is negative and y is positive. We're in the second quadrant again. So when you take the arc tangent of 7 divided by negative 3, you get negative 66. So 180 degrees the other direction, okay, puts you at 113.2 degrees. 113 degrees. Okay? Now what's our magnitude? Our magnitude is 3 squared and 7 squared. 9 plus 49 is the square root of 58. That gives me 7.6. Now we really should be leaving the square roots in here. Square root of 58 and the square root of 41. Don't give the decimals because we're going to use those radicals. We want the exact value. So we'll leave them in radical form on 35 and 36. Okay, 35. Magnitude of A is equal to 36 plus 25. Well, that's 61. And you got to take the square root. So we're going to leave that in that form. Square root of 61 is your magnitude. Now, where are we? I'm going to erase this and make this look a little bit nicer. where are we on the graph for this vector? X is positive and Y is negative. So we are in the fourth quadrant somewhere. Okay, so we can take the arctangent of -5 over 6. So the arctangent of -5 divided by 6. That gives us -39, -40 degrees. Okay, so what is theta then? Well, it'd be 320 degrees. Okay, all right, so now 36, our amplitude is 2 squared plus 3 squared, so 4 plus 9 is 13, square root of 13. And we take the arctangent of -3 over 2. So the arctangent of -3 divided by 2 is -56 degrees, but where are we? Well, X is positive and Y is negative again. Okay, we're still in the fourth quadrant. So -56, so take the answer and add 360 to it. So that gives you 304 degrees. All right, excellent. All right, so let's go through what this is saying. So we have a vector of 40. The magnitude is 40. Okay, we don't know where this is going other than between the two vectors, it's 45 degrees. So I'm just going to give you the distance of 40. Okay, we'll say this is 40. And then B is 70. We'll take this out to here, say it's 70. And this is 45 degrees. All right, so the vectors A and B represent two forces acting at the same point, and theta is the smallest positive angle between A and B. Approximate the magnitude of the resultant force. All right, so the resultant force is like when you're adding them together. It gives you the diagonal of the parallelogram, which is really kind of silly. Okay, so now the question is, how do we do these problems? Well, I can't get the magnitude of this unless I know some information. Well, I know this is 70 down here, and this is 40, right? It's a parallelogram. But I don't have any other degree or length, but I can get this degree by using the law of cosines. So r equals, that's r squared, remember, so we're going to take the square root of each side squared, added together, minus 2 times each side times the cosine of theta. So r, we don't know, but theta we do know. We can get theta. How do we get that? It's a parallelogram. Parallel lines cut by a transversal. So I'm going to use blue here so you can see it. Parallel lines cut by a transversal. So the 45 and theta are consecutive interior angles. So that should be 135 degrees. Now we can just put that in a calculator and get what our magnitude of our vector is. And on my calculator, I get that magnitude to be 102.3. So that is number 37, and they rounded it to 102 pounds. So this is your magnitude, 102 pounds. That's the resultant force. And you would do this with each of these. So let's go ahead and move on from there. So magnitudes and directions of two forces acting at point P are given in A and B. Approximate the magnitude and direction. Okay, so this is north, 75 degrees west. All right, so that's going to be 105 degrees all the way around. Okay, 105 degrees to get there. So we have this vector, that's 90. All right, and the other vector is 60 at south, 5 degrees east. Okay, so that's going to go this way, which is 275. All right, all the way around. So if you take 275 minus the 175. All right, so that's 165, sorry. 90 degrees plus 75 degrees west is 165. So that's 115 degrees. Okay, so 165. So we subtract 165. That's what this is. 90 and 75 more. Subtract those. 275 minus 165. That gives us 111. So theta here is 111 degrees. And this is 60 here. So again, the resultant force I guess I should draw that a little properly. Okay, the resultant force is the same type of thing here. If that's 111 degrees, then we could get any of these other ones. We can go ahead and use this one down here. So they're supplementary. So 180 minus 111 is 69 degrees. All right, and this is 90 because it's a parallelogram. So again, we could do the same thing. So we do the magnitude of r is equal to the square root, because you're taking r, not r squared. Each side squared plus 90 squared minus 2 times 60 times 90 times the cosine of 69 degrees. So let's figure that out real quickly. And I get that to be 88.5. That's the magnitude. All right, so we're supposed to find the magnitude and the direction. Okay, well, this is 69 degrees here, so this is 69. All right. And basically, what you can do is start using your 180s and 270s and try to figure out some of these other ones. You could also use law of sines and figure out some things since we have all these numbers now. Okay, but what you need to get is this direction here is west and then south a certain amount. Does that mean you have to do it that way? No, you could do, it's usually north and south is what we're looking for. And I do notice that I screwed up. The 111 should be 110 degrees, which makes this 70. So my number's off a little bit. So I apologize. So that should be 70 here. And that means my calculation's just a hair off. So that should actually come out to be 89.5 degrees. We'll just say 89 degrees. 89 degrees, 89 pounds. All right, that's your vector right there. We have 60, 90, and we now have 89. All right, so how do we get this other angle? Again, we would have to use either law of sines or something. I'm going to draw it out here, this part of the triangle here. So this is 70, this is 60 for length, this is 90, and this is 89. So you can use the law of sines. So the sine of 70 is to 89, as the sine of theta is to 60. That seems to be easy. You could use the law of cosines too. All right, so let's just do the math. 60 times the sine of 70 equals, and then divide that by 89, and 0.6335 equals the sine of theta. So we take the arc sine of that answer, and we get 39.3 degrees. Okay, so what is that direction? So this is 39 degrees here. Okay, so how do we get there? So if we're heading south, that means we got to turn left a certain amount. Okay, so 39 isn't from the x-axis. That's 15 degrees up here. So 39 minus 15 is 24. To get to this position, that's 24 degrees. Okay, and then how do you get the rest of that? So you want to get to that vector to see what that degree is. If you're heading south, how far are you turning to the west to get to that vector? That's what we're trying to figure out. So this 90 plus the 15 is 105. and then we subtract off the 39, and that's going to be 66 degrees. That's the difference here. Okay, that was pretty complex to get there, but south 66 degrees west. All right, and the magnitude is 89. All right, that's how you do those problems.